All right, now we're going to take a look at the product rule. So this is just another tool in your derivative taking toolkit that can help you, once the functions get bigger and a little messier, it'll help you break them down into something a little more manageable. And a lot of times you'll need the product rule to take a derivative in the future. So what does the product rule state? It says that the derivative of the product rule of two functions f and g of x is equivalent to the second function g times the derivative of the first plus the first function times the derivative of the second. So if you see here, because it's addition, the order doesn't technically matter here, but once you get to the to the quotient rule, it will matter. So I would just get in the habit of doing it in this specific order. All right, so here is our first example here of using the product rule. So you see we have y, the function y is just equivalent to these two polynomials multiplied, the product of these two polynomials. So what we can do here is assign the first factor as f of x just equals 2x plus 3, and the second factor, g of x, equals x cubed plus 1. And then to make our life easier down the road, we'll just take the derivative of both of those factors. So f prime of x equals 2, and g prime of x equals just product rule 3x, and then 1 less is to the second. So now that we have all of that, we can just plug stuff into this handy dandy formula right here. And for now, for the first few times that you do this, I just look back at the formula. Once you do it a few times, it'll kind of just become second nature. You'll remember it pretty easily. But for the first few times, just look at it and you'll get used to it pretty quickly. So you do x cubed plus 1, which is g of x times the derivative of f of x, or 2, and then plus f of x, which is 2x plus 3, times the derivative of g of x, which is 3x squared. And then once you just kind of distribute this all out, we get 2x cubed plus 2 plus 6x cubed plus 9x squared, which just simplifies to 8x cubed plus 9x squared plus 2. And that is the derivative of y, or y prime. So, see, not too bad, right? Here's some few more examples y'all can just do to practice on your own. But one thing you might notice with all of these examples here is you didn't actually technically need the product rule, right? You could just FOIL out the two polynomials and take the derivative just using power rule and you'd be all set, right? So why do we even need the product rule? Is that just like a waste of time, an extra thing to learn, just a little shortcut? Well, not quite. So first off, say you had a polynomial like this. If you were to FOIL that out without a single silly mistake, I would be quite impressed, because that's just so much stuff to keep track of. It doesn't make sense to do it like that. So that's one reason we have the product rule. But also, sometimes there are functions that they aren't polynomials. You can't just multiply them together and then use the power rule on them. You need the product rule to take the derivative. So we do need the product rule and you need to learn it, but it's a reasonable thought to have when just looking at polynomials, because you don't need it necessarily in this case. So that being said, if you have, say, 3 or 4 functions multiplied together, what do you do then? So the product rule is still just the same pattern. You can look here, it's just the derivative of 1 times the other functions, however many of them there are, and then you just do that through, first for f, then for g, then for h, and then however many times you need to. The reason that works is you could redefine the product g of x times h of x as, say, like m of x, and then this whole thing would just be the derivative of f of x times m of x, which using the product rule would be m of x times f prime of x plus f of x m prime of x. And then if you just substitute g of x, h of x in for m of x, you see the first function is just normal. That's what you get here. And then this here will just be another product rule. It would be f of x. Like this would turn into f of x times d over dx of g of x times h of x, and then you just do the whole thing again, and that would eventually just evaluate to this whole thing here. Just trust me on that one. But so just one more example, you can use that triple product, the product of three functions, the derivative of that, find it on your own. It should equal this in some capacity. You might have simplified it a bit differently than I did, but it should be equivalent to that once you get that final answer. And then the big question, why is this the formula? So there is a bit of an unintuitive step, so I wouldn't rely on proving the product rule to remember it, but this is kind of just why it works in general. So you have the derivative of these two functions, f and g of x, multiplied together. If we can just rewrite that in using the form of the definition of derivative, which is just limit as h goes to 0 f of x plus h times g of x plus h, just because the product, you multiply those two together, and then minus f of x times g of x all over h. So, I mean, I broke it up into like two subtracted fractions here, but you can easily just do it like it kind of normally looks, like that, same thing. Now, you keep this same limit, and in the middle, we're going to add these two terms here, which you add the term and then you subtract the term and then you add it again, basically making it so that it's 0. But you're going to add f of x times g of x plus h over h, and then, you're going to subtract it and then add it in the middle, and you'll see why in a second. So if you look here, in these first two terms, both of them have g of x plus h, and in the second two terms, both of them have f of x. So for both of those pairs of terms, we're going to factor those two things out, and what we'll get is this. So still a limit, right? But you have g of x plus h out in the front, and then the two terms here, f of x plus h minus f of x over h, and then same thing with g over here, and f factored out. So this whole thing is probably looking a little familiar right now. That is because if you look here, I just rewrote it here, the derivative of f times g is equivalent to the product rule. So this this g of x plus h out in the front just evaluates to g because h is going to 0, and since g is continuous, that's just going to be like a functional value limit. This turns into f prime of x because that's just the definition of derivative, and then pretty much just the same thing happens, but with flipped functions. F of x is already just normal, and then g prime of x, once again, this is just the definition of derivative. So that is why the product rule works, but once again, I wouldn't remember this proof if I were you. I would just remember the rule, and yeah, that's the product rule.